Hello guys, I'm Daniel Gonzalez and I'm a member of the team that worked on Breazehome 3.0. This video is going to be divided in two parts. In the first part, I will show you how to get Breazehome 3.0 up and running in a development environment. I won't go into each little detail, but it will show you everything you need to know to get developing and adding new features to Breazehome. The second part of the video will show you how to run Breazehome in a production environment and all the things you need to take care of in order to have the app running with SSL and have automatic backups also running. I will also give you some tips that you can use to give maintenance to the app. Before jumping into the development instructions though, I just want to show you this small diagram which shows and explains the system architecture we use. As you can see, our stack uses a number of different technologies, starting with Nginx, which we use as a reverse proxy server, SSL termination, and also for caching of static assets. This one is not important in development, just in production. Next we have Angularjs, which is what our front end is built on. To make Angular work, we use a number of different technologies like Node.js, Grunt, Bower, and some others that you will see in a bit. We also use our own self-hosted Git system called Gux, which replaces GitHub or Bitbucket. This is also not important in development. Next up is Phoenix, which is what the chat system is built on. Phoenix is a web framework which is really nice for real-time stuff. This framework you will have to use only if you plan to be working on the chat system. Now, for the JSON API, we use Django REST framework, which basically allows us to have a RESTful API developed in no time, and it uses Python as a language. Finally, for database layer, we use Postgres. The other stuff you see here is Docker, which we use in production to deploy each of these microservices, and Portainer, which is a nice tool to see and manage Docker containers and volumes from a nice UI and not from the terminal. And that's all for the system design. So, for your development environment, let's start with the database. You can definitely use one of the databases that we have running in our servers for development. The credentials to log into these databases will be provided to you, but this is not ideal. There can be conflicts with migrations since more than one person is using the same database, and some other complications can happen. The best option is to install the Postgres server in your system. I won't tell you how to do this since the procedure is different depending on your OS, but you can visit the download section in the Postgres website at postgresql.com, and there's instructions for all major systems. Once that is done, you can create the database and give it any name you want. Just make sure you remember it, because you'll need it later. The next thing is the Django backend. Of course, make sure you have Python 3 installed in order to get this to work. You can go to git.breazehome.com and log in with your credentials and just copy the link to the Breeze API Django repo and clone it to your local system. Once you do that, cd into the project and run python 3-m vm to create a virtual environment. After that is done, edit the vm bin activate file, which is the file used to activate your virtual environment, and add the necessary env variables for Django to connect to your database. In my case, these are the necessary variables. You might need to add a Postgres password variable also if you set up a password when you install the Postgres server. Save the file and close it. The next step is to run source vm/bin/activate to activate your virtual environment. Then run pip3 install-r requirements.txt to install all the dependencies. This can take some time. After that is done, only if your database is new, meaning it has not yet been migrated, run python 3 manage.py make migrations to create all the migrations based on the models, and then run python 3 manage.py migrate to actually migrate the database. At this point, you should be able to run python 3 manage.py run server and visit localhost :8000 to see the API running. Now that the API is running, let's get the chat server working. You need to have the Elixir language installed. Once again, you can find instructions for that on their website, which is elixir-lang.github.io. Try to install a version close to 1.4.2, but any newer version should also work. Having Elixir installed, repeat the process you followed before to clone the API repo, but this time clone the Breazehome chat repo. After you have the project, just cd into it and create a file under the config directory called dev.secret.exs. This file contains all secrets for your dev environment and should not be committed to source control. Run mix deps.get to get all the dependencies. Once again, this can take some time. Phoenix is one of the dependencies installed through this process. After that, run mix phoenix.server to run the server. This app does not have a front end since it's just used to handle socket connections in the chat system. That takes care of the chat backend. The next and final step is to install the front end. In order to get this working, you need to have Node.js installed, as well as Ruby. Find instructions for those on their websites. The first step is to clone the repo, so follow the steps and get that repo into your local machine. Then cd into the project folder and run npm install-g grunt CLI to globally install grunt, which is a JavaScript task runner, and it is what we use to actually run the frontend. After that is done, install Bower with npm install-g Bower. Bower is used to manage frontend dependencies. Now, the next step is to install some gems. For those who haven't worked with Ruby before, a gem is just a fancy term for a Ruby library. You need to install Sass, which is a CSS precompiler, with gem install Sass, as well as Compass, which uses Sass. Install it with gem install Compass. Those two might take some time to install. When that is done, run npm install to install node packages and Bower install to install front-end dependencies. If at some point during the Bower process you're asked to choose an Angularjs version, just select the newest one. The final step is to create a file named settings.js under the app directory. This file needs to look something like this. It contains all the constants that will be used in the frontend. Of course, make sure to update these variables to whatever values are correct for your setup. And that's it. Now you can run grunt serve to run the frontend. That's all for your development environment. Now let's talk about production. As I said before, in production we use Docker to separate each of the services we talked about into its own container. So the only thing you need to make sure the server has installed is Docker, and a tool called Docker Compose, which is what we use to orchestrate all these containers. Bring them down when there's a problem, run them again when the problem is fixed, or add new microservices to the stack. So head on to the Docker website and find instructions on how to install it in whatever system you're using. Make sure to install Docker Compose as well, since it is a separate package. I also recommend you add your user to the Docker group if you're using a Unix system, since Docker needs sudo access, and you don't want to be typing sudo in front of every Docker command. Once you have Docker set up, all you need to do is clone the Breazedeploy repo to your home directory in the server. This repo has all the projects like the frontend, backend, wiki, and chat system as submodules, so you need to make sure you put all those submodules into your server also. You can do that by changing directory into the Breazedeploy repo and running git submodule update --init --recursive. This will pull all the submodules which are necessary to run the app. You might need to enter your password more than one time in this step. The next step is to create the same settings file we created in development but with the correct values for production. So cd into Breeze desktop and create settings.js under the app directory and put in the correct values for all variables. Once that's done, you can run docker compose up-d and all services will be started and joined to the same Docker network. The first time you do this, it will definitely take some time since it needs to pull all the base images from Docker Hub, build our custom images, and spin off all of the containers. You don't need to worry about public access since one of the containers is Nginx, which takes care of that. Nor do you need to worry about SSL certs and HTTPS access, since we also have some containers that will get all of those for each subdomain as well as take care of renewing them whenever it is necessary. And of course, make sure the DNS records of your domain point to the IP of your production server for all of this to work. If at any point you get stuck during this process, make sure to check the README file for each repo, especially the README for the Breazedeploy repo, which has a lot of nice instructions. Finally, for the maintenance part of things, I will talk about 3 different tasks: adding new microservices, setting up auto backups, and turning off SSL in case there is a problem with a certificate provider. First, to add a new microservice, the first thing to do is of course create your microservice and get it working in development. It could be, for example, a MongoDB instance or a new API to serve some other data. When you're ready to deploy it, you need to make sure you add it as a submodule to the Breazedeploy repo if you need to. The next thing is decide if it needs to be exposed to the public or not. If it needs to, you need to add these variables here and set them to whatever subdomain you're going to use for your new microservice. You do all of this in your Docker Compose file. When the Docker Compose file is ready, just commit it and push it and get it to the production server and just run docker compose up-d. Docker will take care of pulling the image and recreating the container, as well as getting the certificates for it. The next task is setting up auto backups. When you're working with Docker containers, you should make sure that the data that needs to be persisted is put in Docker volumes. If you don't do that, every time your container is recreated, you will lose all the data. So these auto backups make sure that whatever data is in those volumes is copied over to another server to have it as a backup. In order to get this working, you need to first set executable permissions for autobackup.sh, which is in the backup directory here. You can do that with chmod plus x. Make sure that all paths in autobackup.sh are absolute and correct. You cannot have any relative paths, meaning it cannot start with /. In general, make sure everything in this file is correct, the URL to the server you're copying the information to, as well as the credentials to that server. You need to create an empty file named backup_config.json under the backup folder. This is just to avoid permission issues. Install JQ utility for bash to load the JSON configuration. Set up your cron tab to run autobackup.sh every hour, since the script will check if it is necessary to backup or not based on the config file that you created and can be edited from the admin panel in the front end. To set up your cron tab, just run cron tab-e for edit, and you will see that in this file you have this header here explaining how to add an entry to the cron tab. So for m, which is minute, put a 0, and then for every other field, put a star, so 4 stars, and the final field is the absolute path to the script. This tells cron to run that script every hour of every day. And that's it, auto backups should be working. The final task is turning on and off SSL. This is really easy, just run docker compose down from inside the deploy directory to bring all the services down. Then run docker compose-f docker-compose-no-ssl.yml off-d to bring all the services back up but without SSL. In order to revert this, just do the opposite. Bring everything down with docker compose-f docker-compose-no-ssl.yml down, and then docker compose up-d. You need to specify a file for the non-SSL version, since docker compose by default looks for a file named docker-compose.yml, and that's the file that has all the services with SSL. This concludes the installation and maintenance video for Breazehome 3.0. I hope you find this video helpful and it serves as a good reference for the new team members.